prove that a projectile thrown from the ground describes a parabolic trajectory prove that a projectile thrown from the ground describes a parabolic trajectory. In the diagram, we have a projectile of mass m at the point A, and the projectile is thrown with the initial velocity u at an angle theta with the horizontal direction. U is the initial velocity of the projectile at an angle theta with the ground or with the horizontal, and it describes parabolic path, and the projectile strikes the ground at the point B with the velocity v double prime. The projectile strikes the ground at the point B with the velocity v double prime. Now we can resolve the initial velocity u into two rectangular components. Ux is equal u cos theta, which is the horizontal component of velocity. Uy equal u sin theta. Which is the vertical component or rectangular component of initial velocity u in the vertical direction. When the projectile reaches to the point C at instant t equal t second, in that case the projectile will have this type of vertical displacement. This perpendicular is the vertical displacement of the projectile. In this case, the perpendicular Cn1 is equal to y, which is the vertical displacement of the projectile at the point O. The time t is equal to 0 second. At the point C or at the point n1, the time t is equal to t second. At the point C, the projectile has the tangential velocity v prime along that tangent, and the final velocity v prime is resolved into two rectangular components. Horizontal component is vx prime, and the rectangular component of final velocity v prime in the vertically upward direction is vy prime. V prime makes an angle beta with the horizontal direction. The final velocity v prime makes an angle beta with the horizontal direction. Now the horizontal displacement of the projectile at the point C is x, and vertical displacement of the projectile is y when the projectile reaches to the point C at instant t equal to t second. When the projectile is at the highest point A, the projectile has the velocity v along the tangent ax1, and we can draw a normal an on the ground at time t equal capital T1. Capital T1 is the time of ascent, that is the time taken by the projectile to move from O to A. Hmax is the maximum height attained by the projectile at the highest point A. Now we can denote the horizontal range of the projectile. Capital R is the total horizontal range of displacement of the projectile when the projectile moves from the point O and P after describing the parabolic trajectory. When a projectile of mass m moves from the point O, that is from the point of projection O, and moves from the point O on the ground to the point C in AR. When a projectile of mass m moves from the point O on the ground to the point C prime, to the point C in time small t, in time t is equal t second. In time t is equal t second. In time t is equal t second, the projectile the projectile traverses a horizontal displacement x, small x, traverses a horizontal displacement. Projectile traverses a horizontal displacement such that horizontal displacement x such that x is equal o n 1 and x is equal o n 1 and the instantaneous height attained by the instantaneous height attained by the projectile at the point C at an instant t equal t second. An instantaneous height attained by the projectile will be small y such that small y is equal in 1 c. When the projectile moves from the point O to C along the parabolic trajectory, the projectile moves from O to C. Horizontal displacement of the projectile will be x such that this horizontal displacement x is equal O n 1 and at the point C, the vertical displacement the vertical displacement of the projectile will be y such that n1 c is equal to y. X is equal to n1 and y is the vertical displacement which is measured vertically upward such that y is equal to n1 c. Y is the vertical displacement of the projectile and x is the horizontal displacement of the projectile at the point C. Using the equation s equal ut plus half at square. Using the equation s equal ut plus half at square, we get using the equation s equal ut plus half at square between the 2 points O and C. O and C in the vertically upward direction. In the vertically upward direction. In the vertically upward direction, we get y equal uy into t plus 1 by 2 under bracket minus g t square. Y equal uyt plus half minus g into t square. Or comma y equal to u sin theta into t minus half g t square. Y equal u sin theta into t minus 1 by 2 g t square. This is equation 1. This is equation 1 and this is the vertical displacement of the projectile at the point C instant t equal t second. At instant using the equation s equal ut plus half at square between the 2 points O and C for the parabolic motion of the projectile, we get y equal uyt, we get y equal uy into t plus under bracket minus g into t square minus g into t square. So here the displacement s in vertically upward direction will be y. And here displacement s in the vertically upward direction is y. So in place of s we have to write the displacement vertical displacement y. In place of u we can write uy which is the vertical component of velocity, and in place of acceleration a we can write minus g. Acceleration is minus g because we are considering the motion of the projectile in the vertically upward direction. That's why acceleration of the projectile, that means a will be equal to minus g. Again using the same equation, using the same equation, that is s equal ut plus half at square between the 2 points O and C in the horizontal direction, between the 2 points O and C in horizontal direction. In the horizontal direction we get x equal ux into t plus 1 by 2 under bracket g cos 90 degree bracket close into t square x is equal ux into t plus half g cos 90 degree into t square, or comma x equal u cos theta into t plus 0, u cos theta into t plus 0. Therefore x is equal u cos theta into t, that is the horizontal displacement of the projectile when the projectile reaches to the point C in time t second. This is equation 1. X is equal u cos theta into t, which is equation 2, not 1. It should be equation 2. Between the 2 points O and C, we can use the equation s equal ut plus half at square. S equal ut plus half at square between the 2 points O and C. We get in horizontal direction, we can use the equation s equal ut plus half at square. Then we get displacement s in horizontal direction is x. The initial velocity u will be ux, that is equal to u cos theta. Now at the point A, acceleration due to gravity small g acts vertically downwards. We can consider the rectangular component of acceleration due to gravity small g in horizontal direction as g cos 90 degree. G cos 90 degree is the rectangular component of acceleration due to gravity small g in the horizontal direction. This is the parabolic path of the projectile. Projectile was thrown with the velocity u and it strikes the ground with the velocity v double prime. Ux is the horizontal component of velocity and uy is the vertical component of initial velocity of projection. When the projectile is at the point C, the projectile has the tangential velocity v prime. Y is the vertical displacement and x is the horizontal displacement. Acceleration due to gravity, that is small g, acts vertically downwards. Component of small g in the horizontal direction is g cos 90 degree because g acts at right angle to the horizontal direction. That's why the component of g in the horizontal direction should be g cos 90 degree. And using the equation s equal ut plus half at square between the 2 points O and C, s is equivalent to x and we get x as equal ux into t plus half g cos 90 degree into t square. Using the equation s equal ut plus half at square between the 2 points O and C, we get x as equal ux into t plus half g cos 90 degree into t square. We get x as equal u cos theta into t. This is the horizontal displacement of the projectile at the point C. X equal u cos theta into t is the horizontal displacement of the projectile in the horizontal direction when the projectile is at the point C at instant small t equal t second. Or x is equal u cos theta into t, that is the horizontal displacement of the projectile, or comma small t equal x divided by u cos theta. Small t is equal x divided by u cos theta, which is the time at which the projectile moves from the point O to C. T is equal x divided by u cos theta, which is the equation 2. Which is the equation 2. When the projectile moves from the point O to C, horizontal displacement will be x at instant t equal t second. Using equation 2 in equation 1, we get, using the equation 2 in the equation 1, that is putting the expression of time t in the equation 1, we get y equal u sin theta into t minus half gt square. Y equal u sin theta into t minus half gt square equal u sin theta into x divided by u cos theta minus half g under bracket x divided by u cos theta whole square, x divided by u cos theta whole square. Finally, we get y as equal tan theta into x, tan theta into x minus half g x square divided by u square cos square theta, u square cos square theta. Y equal tan theta x minus half g x square divided by u square cos square theta. This is the vertical displacement or instantaneous height attained by the projectile at the point C in air at instant t equal t second. Y equal tan theta x minus half g x square divided by u square cos square theta, which is the instantaneous height, that is the vertical displacement, that is the vertical displacement of the projectile, vertical displacement of the projectile at the point C at the instant t equal t second, at the instant small t equals small t second. So that is y equal tan theta x minus half g x square divided by u square cos square theta. If the projectile reaches to the point C, vertical displacement will be y, and which has the expression tan theta x minus half g x square divided by u square cos square theta. Now we can write down the equation of a parabola, that is x square equal 4ay, x square equal 4ay, which is the equation of a parabola. X square equal 4ay, which is the equation of a parabola, which is the equation of a parabola, and this equation can be this is the equation of a parabola, and this equation can be written as y equal 1 by 4a x square, 1 by 4a times of x square, that is the equation of, this is also the equation of parabola, and vertical displacement y of the projectile can be compared with this y, with the expression of y which is connected to or regarding the equation of parabola. Maximum power of y in this expression is 1 and maximum power of x is 2. That's why y to the power 1 is the function of x square. Similarly, in the equation of parabola, y to the power 1 is also the function of x square, is also the function of x square. Hence, we can say that y equal tan theta x minus half g x square divided by u square cos square theta is the equation of a parabola. So we can say that hence the parabola, hence the projectile thrown from the ground, describes a parabolic trajectory or path. Hence the projectile thrown from the ground describes a parabolic trajectory, projectile thrown from the ground describes a parabolic trajectory. When the projectile of mass m is thrown with the velocity u, it describes this type of parabolic trajectory. This curved path is the parabolic trajectory. The equation of this curved path satisfies the equation of a parabola. That's why this curved path followed by the projectile is a parabolic trajectory or path. additional information, that is we can discuss the use of the equation y equal tan theta x minus half g x squared divided by u square cos square theta. At the highest point A, the horizontal displacement at the highest point A, or at A, that is at the highest point A, the horizontal displacement x is equal, the horizontal displacement x is equal capital R by 2. At the highest point A, the horizontal displacement will be x is equal R by 2, capital R by 2, where capital R is the horizontal range of the projectile. Equal 1 by 2 r equal 1 by 2 u square sine 2 theta divided by g, that is equivalent to x, that is equal to x. At the point A, or at the highest point, y tends to h max, which is equal to tan theta x minus 1 by 2 x square divided by u square cos square theta equal tan theta. Putting the expression of x, we get u square sine 2 theta divided by 2g minus half minus g by 2 u square cos square theta into, putting the expression of x, we get u square sine 2 theta divided by 2g whole square equal tan theta into u square by 2g 2 sine theta cos theta minus g divided by 2 u square cos square theta, g divided by 2 u square cos square theta into u to the power 4 sine 2 theta whole square divided by 4g square equal u square by 2g u square by g into sine theta by cos theta into sine theta into cos theta is equal minus u square divided by 8g u square divided by 8g cos square theta under bracket 2 sine theta cos theta whole square equal u square by g u square divided by g sine square theta minus 1 by 8 cos square theta into 4 sine square theta cos square theta u square by g sine square theta minus sine square theta by 2. Therefore, u square sine square theta divided by 2g, which is h max. H max is equal to u square sine square theta divided by 2g, which is derived from the formula of the instantaneous height y. Here h max is equal u square sine square theta divided by 2g, which is derived from the expression of instantaneous height y. That is, from the expression of y we can prove the expression of h max. Y equal tan theta x minus half g x square divided by u square cos square theta. From this expression we can prove that h max will be equal to u square sine square theta divided by 2g. And here x is equal to horizontal displacement, x will be equal to r by 2 at the highest point, and r is equal to u square sine 2 theta divided by g. From the expression of y as equal tan theta minus half g x square divided by u square, we can prove that h max, or that is maximum height of the projectile, will be h max, which is equal to u square sine square theta divided by 2g.